Okay, this is chapter 8 review. These are all book problems, but you could, if you don't have your book, you can just write the problems down here. The only thing missing from this are the directions, but I can tell you what the directions are. So for number 14, there's really no like terms. There's nothing you can add together, but they want us to put this into standard form. So remember, standard form is just where you write the highest exponent term first, and the very last term you want to have is your constant number. So that's all you have to do for number 14. Number 19, we have a subtraction problem. So since there's a minus sign in front of these parentheses, do you guys remember you can add the opposite? So if I change this to addition, I need to make all three of these terms opposite. So this will become negative, positive, negative. And then we're going to add together our like terms. So here I have an a squared. You can think of that as 1a squared plus negative 2a squared. So that'd be negative a squared. And then you have a positive 5a, and this is now a positive 4a, so plus 9a. And then we have a negative 3 plus another negative 3. So think of like losing 3 yards, losing 3 yards. So that's negative 6. And then you're finished. Okay, so we're not doing arrows on that one because we're just adding, and you want to add like terms. Okay, here we want to do the distributive property because there's not a plus or minus sign. This means multiply. So we're going to do our distributive property. 3x to the third, then 3x times x is 3x squared, and then 3x times negative 7 is negative 21x. And you're all finished because those are all unlike terms. Okay, we've got a binomial times a binomial. So you can do your arrow method, you can make your area model like this, or you can do the FOIL method. So whatever method you like to do, we're going to get the answer to that. So I'm going to do the FOIL method. 10x squared is my first. My outside is 4x, and my inside is 25x. 4x, 25x would be 29x, and then 5 times 2 is my last, and that would be 10. So that's how you get your answer all at one time. If you did this chart, that's great, but then your final answer should look the same as mine. All right, 33, I hope you remember, you do not just take 5x and square it and 4 and square it. It means 5x plus 4 times 5x plus 4. So I'm just going to get rid of that 2, and I'm going to just write 5x plus 4 like this. And then again, you can make the chart method, or you can do the FOIL method. Do whatever method you want, push pause, and then check your answer, please. Okay. Number 37, we are supposed to find the area of the shaded region. So it's like a rectangle donut. So we would need to find the area of the big rectangle, and then we're going to subtract the area of the small rectangle. Okay, so the big rectangle is the 2x plus 5 and the 2x minus 5. I'm going to show that work right here, and I'm going to use the area model because I know some of you guys like this the best. Okay, so I get 4x squared, 2x times 5 is positive 10x, 2x times negative 5 is negative 10x, and negative 5 times 5 is negative 25. Notice these cancel, so all we have is 4x squared minus 25. That's our big rectangle. While I'm still with my yellow marker, I'm going to do the small rectangle. Do you guys see that same thing is going to happen? We have x plus 2 and x minus 2. Okay, that's a negative 4. So these are going to cancel. But when you want to show your work here, we're not done. We want to find the area of the shaded region. We want to take the big answer minus the small answer. Make sure you write this in parentheses. So our big answer is 4x squared minus 25 minus, and our small rectangle's answer, because those cancel, is just x squared minus 4. Okay, now this question is a subtraction. This is not a multiplying 4 arrows. This is a minus or subtraction. So this is like what we did here. So we're going to add the opposite. I'm going to change to a different color so it shows up. So I'm going to take this and I want to add the opposite. Now, what is 4x squared plus negative x squared? 3x squared. And then we have a negative 25 plus positive 4, which is negative 21. So this is the answer to the shaded region. You will see one of those on your test. So make sure you guys are doing this worksheet to help you, or this book problems to help you learn and help remember how to do these problems. Okay, next page is it still from your book, page 547? It's not responding. I'll give it a second. There we go. So now what we're asked to do on number 39 is factor out a GCF, all right? This is a kind of tricky one. So think what number divides into 14, 21, and 35. If you're thinking 7, you're correct. 7 goes into 14, and it goes into 21, and it goes into 35. We have an x squared y, an xy, and an xy squared. So we can take out an xy. They all have an x and a y. So what do we need to multiply by 7 to get us back to 14? And what else do we need with xy to get us to x squared y? We need to multiply by 2x. 7xy times what would leave you to negative 21xy? Well, look, we already have the xy, so all we need to multiply by is negative 3. And then finally, 7xy times what would lead you to 35xy squared? 7 times 5. And then we have xy, but we need it to be xy squared, so we need a y. And then that's all you can do. That's factoring out a GCF, and we can't factor this anymore, so you're all done. All right, now we have a trinomial to factor. They have no GCF. There's nothing they all have in common. So this is going to be like the opposite of the FOIL method. So remember, x times x gives us x squared, F-O-I-L. Our last term is 15. So remember, you want to start with the 15 and think, what multiplies to 15? 1 times 15 and 3 times 5. Which will help us get to an 8? The 3 and the 5, but we need to be careful on our signs. What do they both need to be so that they add up to negative 8? They both need to be negative. And do you guys agree that works? Negative 3 times negative 5 is 15. We want that. But when you add them up, it equals negative 8. So they both are negatives. Remember, you can use your area model to make sure that this leads back to where you started. Okay, this one I think is a little bit easier because everything's plus. These are the easiest. And you think of things that multiply to 20 that add up to 9. So if you like to list all the things that multiply to 20, that's fine. But some of you guys might already be automatically thinking, oh yeah, 4 times 5 works for multiplying to get 20, and 4 plus 5 is 9. So we're going to use the 4 and the 5. Okay, this last number is a negative. These are the trickiest because you need one negative and one positive. Okay, so a lot of kids think, oh, 2 times 3 is going to work because 2 times 3 is 6 and 2 plus 3 is 5. But this is actually not going to work because you need one of these to be negative and one to be positive. So also, 1 times 6. How can we use 1 times 6? Because if we want one of these numbers positive and one of them negative, if you would make your 6 negative and your 1 positive, do you see how that adds up to negative 5? So this is what we'd want to do, a positive 1 and a negative 6. All right, 64, 65, and 66, these are much harder because your first term has a number with it. So I really think the best way to do these is the area model. Okay, so for 2x squared, I am sure it's 2x times x. But then you honestly just need to try different numbers that multiply to 20 till you figure it out. Okay, so let's say I'm going to be, all right, I'm going to do 5 times 4. So if I put the 5 here and the 4 here, let's see if we can get this to work. 2x squared is good. We have a 4x, we have a 10x, and then 4 times 5 is 20. So we have the 20 and we have the 2, but these are not going to help us get to negative 3. So we're going to try something else. Let's try flipping our 4 and our 5. So I'm going to, instead of writing it like this, I'm going to put the 4 here and the 5 here. So now 2 times 4 is 8x, and x times 5 is 5x. Okay, we're going to be able to get it now. We want it to be negative 3x, and we want this to be negative 20. So Do you think we want the 8x to be negative or the 5x to be negative? We want the 8x to be negative and this to be positive. Okay, so put a negative right here with your 4, and then let's fix everything. The 2x squared we've not messed with, that's good. X times 5 is positive 5x. Negative 4 times 2x is negative 8x, and now we need to fix this. Negative 4 times 5 is negative 20, and this is what we want. We want this to lead back to where we started. So we want the 2x and the positive 5 together, see how they're up here together? And we want the x minus 4 together. So that's the correct answer. Okay, here we're going to definitely be 3x and 3x, but then we need to think, what would we do to get a negative 10 and an, sorry, this should be 3x and x. What do we need to do to get that negative 10? Okay, so we have 3x and x, and we want to get a negative 10 and we want to get a negative 13. Let's put a 5 here and a 2 here. Go ahead and try to finish that. We can make it work with the 5 and the 2. See if you guys can decide where the negative goes and where the positive goes. So pause the video and try to solve it yourself. So the final answer is 3x plus 2 and x minus 5. You guys can watch me do that problem to help you guys figure it out. Okay, 66 is a pain because you don't know in the very beginning if it's going to be 6x times x or 3x times 2x. So what I'm going to do over here is I'm going to make two area models. It might be 6x times x, and it might be 3x times 2x. And then we're just going to try to figure it out. The good news is 5, we know it's just 5 times 1. So we don't have a lot of options with 5 because we know it's 5 times 1, but it might be the 5, 1, or it might be 1, 5. It might be 5, 1, or it might be 1, 5. So, I don't think it's going to be this one. I think we're going to use this one. I think this we can make work. Okay, so again, you have to just try different things until you get it to work. Again, this one doesn't work, but I'm just gonna kind of show you. You just have to kind of play around with it until you figure it out. But that's 11, or if we subtracted them, it's 1, but definitely we cannot get to a 7 with that. So let's try to work this out and get it to a 7. So 6x squared, 10x, 3x, 1 times 5 is 5. We want a negative 5 and we want a negative 7. We want a negative 5 and a negative 7. So to get these two to be negative 7, this would need to be negative. So that makes this 5 negative and this positive. Now let's check everything. This we've not changed. 2 times negative 5 is negative 10. 1 times 3x is 3x. 1 times negative 5 is negative 5. This is what we want, so that means this is the correct answer. And go ahead and write it in your parentheses. 3x minus 5 and 2x plus 1. I don't know if you guys remember this from section 8.7. It's the difference of two squares. Y times y, 9 times 9. You guys remember the signs? If we want everything to cancel, we would need a negative and a positive. And finally, this is one of those special ones where we're going to try 6 and 6. I know lots of things multiply to 36, but if you make them both a 6, do you agree it's going to end up adding up to a 12? And you could write this answer if you want, you don't have to, as x plus 6 squared. Is that it? Hope we're done. Let's see what's on the next page. This is going to help you guys study for your